Welcome to the second lesson of the Game Dev Club. Basically, if you came to our Friday meeting, we're basically going over it again. First, because the Friday meeting was a bit of a fiasco. Right now, you'll have a full, close to an hour to learn C#. And second, if you weren't here on Friday because of other major club meetings, then you'll be able to learn today. So, let's begin. Now, we know you have, I told you to open up Unity. So you should see a new product in Unity, and you should see this. Your first step to becoming a programmer is to open up a C# script by right-clicking in Assets. You'll see a window. Hovering Create, C# script. Okay, now you can name your script whatever you want, except you can't have any, except don't use any spaces or numbers in your name. So you can, in my case, I'm going to name this my first script, and without any spaces, and I'm just separating words by capitalization. So we made our first script. Hooray! But I don't see any code yet. So in order to make code show up, you double-click C#, or the C# script, and wait a couple seconds. Relatively soon, you'll see something like this, Visual Studio. Now, what is Visual Studio? Basically, while we wait for this to load. Oh yes, if you have to sign in, then the credentials for signing in, although they're super insecure, are username. The username is tinogamedevcommunity@gmail.com, and the password is hellogames456. However, since I'm sharing this with a bunch of people, it's extremely unsafe. I would recommend for instead of using this, is to make your own Microsoft account in order to use Visual Studio. So, but for now, if you haven't made a Microsoft account, then just use these credentials. Eventually, though, please make your own Microsoft account. Okay, so with that out of the way, I'll just leave this here for now. I'll delete it eventually. Now we are in Visual Studio, and I got cut off from opening from talking about what Visual Studio is. But Visual Studio is basically an IDE, and basically it's just a glorified document, a glorified word processor. You can type words into it, and text will appear. That's literally all it is. However, Visual Studio also formats your text so that the computer can read it, and also adds a bunch of extra tools that help you write code specifically. And you will see that eventually. So, for starters, just so you can see what a computer can do, start by typing in print. Notice that a box appears. That is how Visual Studio helps you sometimes. It's called autocompletion. If you type in a part of a word, it'll give you a bunch of options that you can pick from. In this case, we want to use a print function. So with that selected, you can press enter, and the entire thing will complete. Now, you must type in parentheses, opening parentheses, and the computer will automatically offer a closed parentheses for you and put your cursor in the middle of them. This is because you will be typing something inside of it. Try typing in 5. Now, make sure you save by hitting Control S. And then, however, if you try to run, what people might think in order to run code is that you would just start running the game right away by hitting play in this up here. However, if you hit play, nothing really happens. Look at the console. The console will be how your computer communicates with you. And print is supposed to make things appear in the console, but you don't see anything. So what happened? Well, basically, in order for scripts, Unity only runs scripts if they're attached to game objects. So, based on, like, from what you learned in the previous lesson, you would create a game object, and then by right-clicking inside the hierarchy, and then picking whatever game object you want to make, and then you would have to add the script as a component, because scripts are components. So you would click Add Component, and then type in the name of the script that you want to add. So in my case, I named it My First Script. So in Add Component, if I type in a piece of My First Script appears. So that means Unity recognizes that script. Now you can hit Enter to add it, and My First Script is in the inspector as a piece of the cube. If you don't see this transform cube, mesh renderer, block slider, My First Script, or like any like transform component, then you'll have to select the object first in order to add a component to the object. So, that out of the way, pay attention to the console as I run it. 5 appears. Hooray! You got your computer to do something. That is, print text to the console. Notice that no text randomly appears inside the game view, because that is not what print does. Print doesn't make things appear inside the game. Print makes things appear in the console, which the player won't see. So based on that, you can kind of tell that the console is mainly used for debugging purposes, because only the developer usually sees it. Debugging is basically just looking through your code to see if anything's wrong. Print see how much force a computer thinks a rocket has. Things that the player won't care about, but the developer needs to know in order to fix his game. Okay, so based on what you just saw, you can kind of guess that what print does is it makes things appear in the console. So what if we want to make text appear in the console? Well, if we type something like hello, there's a red line. Now, what does this red line mean? It means that the computer doesn't like what it sees in the text. If you hover over it, you can see a description, but usually that's not very telling. So I'll tell you now, the computer does not view hello as something it can print. However, if we add quotes to it, the red line disappears, which means that there's no error. And if we try and run the game again, make sure clear on play is here, because basically what it does is it erases the console before printing new lines. You can also just clear the console by clicking clear over here in this in the far left under project tab. So you can click clear if you want to, and then run the game. And wow, you got it to print text. Hooray! So what can we learn from this? Basically, in order to print any text, you have to put quotes around it. And in order to print, however, if you want to print numbers, that's fine. You can just type in the number. Let's see. Now, let's give you a little something to work on for like 30 seconds. Print I like Unity. And then print 5 is my favorite number, or you can actually replace it with anything. So for 30 seconds, just try printing these out, or actually even 15 seconds, I guess. 1, 2, 3, 4, 5, 6, 7, 8, nice, 9, 10, 11, 12, 13, 14, 15. Okay, so we're hopefully you might, if you haven't been able to type it out, at least you have an idea of what's supposed to go on. You would have to print I like Unity in quotes, because it's words, and then what's interesting here is that if you did it on accident, you can actually type numbers into your quotations. Well, number. I forgot to type in number. My bad. So, and if we run the code, make sure you save in order to make things run. Because if you don't save, it won't run your most recently typed code. Everything prints. You type I like Unity, 5 is my favorite number. So the reason I try and teach print early on is because print is actually how you're going to learn a lot about your games. Again, I said it's useful in debugging. Unity doesn't show all of the numbers that you might want to see, and code code and the print function is how you'll see what you want to see. Get Unity to spit out information. Okay, so now let's see. Let's do this. Actually, not do this, but rather I want to explain to you how I view computers now. Basically, if you look up here, let's draw actually a cool way of thinking of the computer. Here's your computer. Whoops. Here's your computer with a mouse, of course. Your computer is kind of like a guide, and your computer has like this space that he can create things in. Your computer is a little bit limited in that it can only create numbers without decimals. There's 6 things that the computer can create. 5 things the computer can create. Numbers without decimals, numbers with decimals, numbers with decimal places that have an F at the end, and then anything with quotes around it. Well, yeah. Well, actually, don't ignore that. So you could anything with a quote around it, and then it can also create true or false objects. So basically, what these things are called are data types, and there are specific names for them. So I'm also going to teach you something else that's cool. You can actually if you type double slashes, your computer will completely ignore what you type. So if I typed print 5 in here, but since there's double slashes, Unity won't run it. It won't run print 5. So comments are how I'm going to show you. Teach you things in like human readable text. So computers can make integers. We'll shorten this to int, and they're numbers like 5, 1, 3, 123, 10,023, -0, -10. Numbers without decimal points. It can also create doubles, which are decimal place numbers with decimal places. 9.0, 12.34. It can create floats, which are decimal places with an F at the end. So you would have to type in 5.0F, 1.1F, 123.571F. You don't have to care about how many places after you don't really have to care about how many places after the decimal point you go yet. You might want to care about it eventually, but not now. Strings, which are things in quotes. Hello. Numbers in quotes are still strings. Symbols in quotes are still strings. And then booleans. In C#, we call them bools, though, just to be convenient. So literally, there are only 2 types of booleans, true and false. Unfortunately, there's no maybe, which sometimes you would want, but computers don't like that. Okay, so now, the reason I'm showing you all of these data types is now I'm going to show you how, first, before that, let's go back to what we typed when we printed print 5. Because basically what the computer did here was, let's see, let's remove all of this stuff, was that it created an int. Whoops. And then it told the int to display on the computer, to display on like the monitor in the console. When you typed in print hello, if you type in print hello, it creates in this world a string, and then it tells it to print to the monitor. So now, the reason I'm teaching you data types is because now we're going to show you how to store them in things called variables. Variables are basically like boxes, but it's a very specific way you make them. Because first, you have to know what do you want to store. Do I want to store a number without decimal, an int, a number with decimal, double. We'll explain why I use floats later. But if you want to store a float, you need to know if it's a float. Let's say I wanted to store a string. Now, the first thing I would type when I want to make a variable is string. Notice it turns blue because it's a special word denoting a data type. Now, the second part of making a variable is you name it. So I can name this text. And in this case, they don't care how you name it. Visual Studio doesn't care whatever you name your variable. And then you type in equals, because you've just made a bag that contains a string called text, but it's not actually holding anything yet. Then you type in whatever you want to put in the bag called the variable. So in the bag called text, I want to type in hello. And hooray! Basically what this does in our model of the computer, let's see, what's the shortcut? Whoops. What we did in our model of the computer was we told it to make a bag, hello, like a lunchbox perhaps, and we named it text. And inside of it, we told the computer to put text called hello inside of it. So now it stored a string. Called hello inside of the bag of text. We're not restricted to storing strings, though. We can also store things like ints. You can say int num is equal. Yeah. Okay. You can store things like ints 1, 2, 3. You can store doubles equals 5.5. And it won't double. You have to name it though. Decim num equals 5.5. You can store anything as long as you know what you're going to store. And then basically what you can do is you can actually reuse whatever you replace instead of having to type in hello every time, you can just type in the name of the variable. Make sure it's case sensitive, so you'll have to type it in as is. And then if you print this, Control 7. If you run the code now, it'll print hello. Even though we put text in print, we told the computer that text is hello, and therefore replaced in the print function, replace text with hello. Note, again, just to make a point, these don't need any quotations because they are simply bags. They aren't any actual objects like strings or bools. They're just pointers to the object that you actually want to use. So that's how you use variables. So let's give you a little more practice. Try storing 314159 in a variable. Try storing I'm a part of the game dev GDC in a variable and try storing 5.98f in a variable. I'll make kind of a sheet for you. Actually, let's copy this. Let's see. There we go. So here's a reference to what the data types are and the kinds of things that they would represent, and then try doing these assignments. I'll give you 15 seconds. Yeah? It is hard to see the green text. Make it darker? Wait, where? Okay, dark theme? General theme. Dink. Okay. Wow. Okay. Is it harder to see? Or enlarge font? Yeah, that's what I was gonna do. Okay. Okay. Let's see. Before I do that. Okay. Because of by request, we will be increasing the font size because text is kind of small. Oh, they call it 10. What? Let's make it 20 is too large, but 18 is a possibility. Yes, there we go. Hopefully you can see that now. Okay, so basically, in order to store 314159 in a variable, notice that it's a number without a decimal. What does that mean? If we look in this reference, we can see that ints are numbers without decimals. So in order to store it in a variable, in order to store 314159 in a variable, we have to make a box for it that will contain an int, because that is what 314159 is. Int, name it whatever you want. Num, I'll just name it num. But actually, you know what? For the sake of example, you can name it anything you want. ASDF, the computer will not care. 314159 is what we want to store in the box called an int. Semicolon, because I should have made note of this before. You must end all your lines of code with a semicolon, except for empty lines and a few other exceptions, like void start in these brackets. Through experience, you'll probably learn about which lines are supposed to have semicolons at the end and which ones don't. In any case, this is how we created an int. We made a variable storing 314159. If you want to just the same thing goes for all the other ones. Since I'm a part of the GEC has quotes, we know it's a string. So we type in if we want to store it, we have to say the data type is a string. Give it another name, JKE, equals I'm a part of the GDC, and it with a semicolon, like any other line. If we want to store 5.98f, notice that it's a decimal place with an f at the end. It has a decimal and it has an f at the end, so it has to be a float. And float, name it whatever, is equal to 5.98f. And that is how you store floats in variables. Okay, so now, are there any questions, or shall we move on? All right. Well, now that you've learned about that, let's talk a little bit about some operations, actually. Some cool things you can do with your data. first, you can instead of setting something to a number 1, 2, 3, 4, you can actually use an equation to set numbers. Whoops, int, give it a name. What do you think I'll give you 5 things to think about. Actually, let's make this easier. 5 plus 5. I'll give you 5 seconds to think about what num would hold. So in this case, because 5 plus 5 is not in quotes, if we have quotes, it would be a string, and the computer would take everything verbatim. Basically what it does is it actually adds 5 and 5, and the result, if you see in print, will be 10. Basically, I save it now. I'll go back to Unity and make sure it's not running, and then run the code, and it says 10, not 5 plus 5. So basically, that's how you can start using your computer as a calculator. Your computer just whatever operation it sees, it just computes for you. If you want, basically, in order to add, that's obviously the plus sign. Subtraction is the negative sign. So what would num hold here? Num would hold 0. As 5 minus 5 is 0. How about times? Times is the asterisk. So in this case, num would hold 25. And to divide, it is the backslash. So divide. So in this case, num would be 5 divided by 5 equals 1. And I guess if you wanted to see it, just for just to make an example out of it, 5 divided by 5 is 1. Hooray! Okay. Now, here's the weird thing about strings now. Let's see. String text equals hello plus I plus like plus unity. So notice that there's no red line here except for this red line here, because there's no variable called num. So notice there's no red line. What you can do with strings is that you can use the plus sign to kind of smush strings together into one string. So if I print text now, it'll actually print hello, I like unity without spaces, unfortunately. So in order to add, it'll also consider space a character. So in order to put spaces in between them, you will have to put spaces in front of. You'll have to actually type in the space. So now if I run this, hello, I like unity will now be properly spaced out. Hooray. Okay, so just now you learn that you can do math, and just now you learn that you can smush strings together. Smushing strings together is a process called concatenation, if you wanted to use the cool programmer word for it. Okay, now, what's next? How about we teach you about the update, why there's something called start and why there's an update. So notice how, well, first, just from the name, what do you think start and what do you think update would do? Well, basically, if you saw that we've been typing everything inside the brackets of start, here, these two, everything got printed once. And then we typed nothing in the brackets of update. What update will do is it will repeatedly do whatever is inside of it. So update, if you run this now, it's constantly printing hello, I like unity, because that represents how much we like unity. Okay, so basically now you know the difference between start and update. It's a very simple difference. Start is called once at the beginning, the moment you start playing your scene. Update is called every frame. It says update is called once per frame. And if you know if you've heard a little bit about animation, basically a frame is a picture they show you on the screen. The reason it's called a frame is because they keep replacing the picture on the screen with another new picture on the screen, and another new picture on the screen, another new picture on the screen. So if you had a picture like this, and a picture like this, and a picture like this, if you play all the frames at once, it looks like the hand is moving. And basically, each time the frame changes from here to here, it calls update. So when you move here to the next frame, it calls update. So I forgot that that won't show up on the video, but you can kind of understand. Okay, so that's what update does. A very simple difference. Okay, what next? How about I teach you about how to make life easier for you when you want to do a lot of stuff repeatedly. Okay, so take a look at what I'm going to do now. It's very specific, so make sure you take a look. Void my function, open parentheses, close parentheses, space, well, and then brackets, curly braces, mainly, specifically. And then if you type print, I made a function, you can kind of guess at what you just made now, just based on what I just did. If you type print, I made a function, and then you try and run Unity, nothing happens. So what happened here? Well, we can kind of see what we actually did if we type this portion into this portion following the void into start. So if you end it with a as always, you have to end things with a semicolon. Now watch what happens. So when I run it again, it prints I made a function. So what happened here? The computer runs through the start function, and it comes across this. So then it checks, it goes down all of these functions, void start, void update, my function. It sees that this text is the same as this text, and so it it tries to execute everything that is inside of that function. And that's why since we told the computer to execute print if it sees this function, my function, it printed I made a function, even though in the start method we didn't actually tell it to print anything. So that's what functions are for. If you want to do a lot of stuff repeatedly, well, like if you're going to use the same lines of code a lot, you would want to use a function in order to repeatedly do that. So I guess for a little bit of practice, make a function that prints the sum of 100 divided by 100 divided by 3 times 9 plus 5, 54. Just do that for 30 seconds. Oh, but before that, I should explain the format. For now, functions start with void. Type in the name of the function. Separate the words by capitals. You cannot use spaces, and you cannot start the function with a number. End it with with these parentheses, and then type in curly bracket, which should be, for most computers, is under the plus and minus signs. Curly bracket, and then enter. And then Visual Studio will modify the text to open up the brackets for you. So try doing this. Make a function that prints the sum of 100 divided by 3 times 9 plus 54. I should make a note that you should not be making your functions inside of avoid and update. Basically, if you really wanted to know, it basically means that when you make the function inside of update, you can only use the function inside of update. If you try and type in start in the start brackets, my function, it doesn't recognize it. However, when you type in my function inside of update, it does. So basically, it only recognizes the function if you the function within the curly brackets that it's in. However, if you move my function to outside of the curly brackets, suddenly both of them will recognize it. I can type in my function, and I can type in my function, and it'll recognize it in both places. Notice that this is because my function is within these very large set of brackets, and therefore my function is recognized everywhere within these two brackets. So recognized in start, and it's recognized in update. So basically, the answer to this, in order to make a function that prints the sum of 100, I called it a sum. That is completely wrong. You should call it the answer to. That was weird. I'm sorry. Now, the function would be void math, I guess you could call it. Cool math. You would type in void, the name of the thing you want, the name of the function, parentheses, and then brackets, curly braces. And then you would type in print 100. I guess you can make a variable. Or if you wanted to, you could just type it inside print directly. 100 divided by 3 times 9 plus 54. And if we call the function, cool math, notice how it pops up in the autocomplete. That's already a good sign. The computer recognized the function. I end up with parentheses and semicolon. And now if I run it, well, you can already see, it prints the answer to whatever you typed in, 351. Hooray! We learned how to do functions, and now we can do a lot of repetitive tasks really easily. Because what if you wanted to do something like this? If you wanted to do like a computation like x equals, like double x equals 5.6. Let's make that. And then double n equals 12.8. And then you wanted to like do a bunch of extra math repeatedly, or if you wanted to print, say, a lot of lines at the same time, you could print hello, and then you wanted to make another line, so you wanted to print my name is Ryan, and I'm here to help you learn code. Instead of having to print instead of having to type print all this text, you learn code. Instead of having to print all of this text, which is very tedious, if you wanted to print this multiple times, you want to use it elsewhere in your code, you can just type cool math as many times as you want, and that's a lot faster than having to type 4 lines of code with all that text every single time. It doesn't look useful now because all we're doing is printing text, but it becomes very useful when you start doing more complex things. Okay, so now, how about I teach you about return? Let's watch what happens when I do this. Double cool math. Actually, no, instead of this, let's go back to our my function. String my function. Return I made a function. What happens when we call my function? In start, obviously. In start my function. Well, if we go to Unity and we run it, nothing happens. So what do we just do with return? Well, you'll be able to see if we use the print function. Again, I'm saying the print function is important to help you learn, because that's how you see things with your own eyes. Print my function, and you see that my function returns I made a function. What happens? I made a function. It gets printed. Doesn't this look kind of similar to print I made a function? So basically what return does is it takes the object, remember I mentioned your computer can make ints, bools, whatever. It looks at the what it returns and then replaces the function with the return value. So that's why when I typed in my function, it looked into my function, looked at the return value, saw this, and the computer says, oh, since it's returning that, I better replace this function with I made a function. And that's basically what return does. It replaces a function with the return value. Now, what do we do with string? Well, basically, like variables, the computer has to know what kind of thing you're returning for some reason. So basically, if you typed in int, what would happen? Look at the red line. It says it prints a red line for it shows you a red line for the return value, because you can see that because it says quotes, it's obviously returning a string, but I told the computer the function is going to return an int. So the computer complains saying, wait, this is not the same as this. This string is not an int, and therefore it gets angry. So if we wanted to return an int, we would have to type in something that is an int, a number without decimal, and then it stops complaining. So what is void then? Void basically means if you don't actually want to return anything, and you just want to do stuff like print lines of code, then you can type in void and you won't have to deal with returning anything. So that's what void does. So now you know what return does. Okay. Should I do this? Okay, I'm gonna class is ending soon. Well, this lesson is ending soon, so I'll teach you something a little bit off tangent before I try and move on to the next section. Try typing in public. Make a variable outside of start, update any function, except add public to the front of it. Public ints hello. And you also don't need to add any equal signs, by the way. Public double cool num. You can start with these with lowercase letter, or really anything you want. Now watch what happens in Unity. Look here in this script component that you made for your objects. What should have appeared is fields. You can see that the variable name appears on the left, and the value for that field appears on the right. What you can do is actually change the values inside of these fields. So we said hello was an int, so as long as we type in an int and not like a double, it won't let us print periods. If you type in an int 1 2 3 4, hello will become 1 2 3 4. And if we type in a double, in this case we said it's a float, so we can type in periods. 123.4.509 is what coolnum will be. So you're starting. This is part of how Unity connects to code. You can create fields by making public variables outside of start and outside of update. Just to show you what happened here, if we print coolnum now, and we go in here. Whoops. Well, first notice that coolnum is 0, and it prints 0. And I told it to print coolnum, even though we didn't set coolnum to any number. So what happened here? So basically, what we did what Unity does is it looks in the script and it sees coolnum and it says, oh, coolnum is 0. So then in the script, when it looks in print, it looks here. First, it looks around for any coolnum variables. It sees this, but it sees that it's not attached to like an equals 5, say. However, so the next thing it does is it looks in Unity, and it sees in the inspector coolnum is associated with 0. So then it replaces coolnum with 0, and then 0 got printed. If we typed in anything else in coolnum, it would be replaced by whatever we typed in. If you couldn't see, it's 1234.9985, which is exactly what we typed into coolnum. So that is basically what that's part of how you can use Unity in. This will be that's the setting public variables out here is usually for like utility purposes. If you don't want to have to go back into code and set values, like if you wanted to set your player's speed, say, and you didn't want to have to go to Unity, you didn't want to have to go back to Visual Studio to do all your code editing. You can just set it right here, and you can use like a public double speed, and then you could set the speed in the inspector rather than having to go back to code. It's a utility thing usually. It's very convenient though. Okay. Now, let's see. We have 7 minutes. Let's see if I can teach you parameters, and then I'll try and teach you get component. If not, then you can look up we don't get to get component, you can just look up get component. But either that or we'll be teaching you that in the next lesson. But I really want to show you now, so I'll see if I can get to it. But first, parameters. Try this. Int num or string hello. Notice that no red lines appear. That means the computer says, oh, this is okay. But why is it okay? Well, let's see. Now watch this. Print num, print hello. Also no red lines. These look like variables, but we didn't set them to anything. So what's going on? So watch what happens when we call the function First, you see that there's a red line suddenly. So that means something's wrong. Now, if we type in an int and a string, suddenly the red lines go away. So, and if we go to Unity and we run the game, it prints 5 and hello. Even though we didn't specify in the function to print 5 and hello, it's well, actually I should probably change it to something else. ASDF. Even though we didn't specify in the function to print 5 and ASDF, Unity will still print 5 and ASDF. So basically what's going on is when we do this, int num string hello, we basically create kind of slots for functions. And basically when you call the function, C# or Visual Studio will ask you, what do you want to set num to in the function? What do you want to set hello to in the function? And basically what we did here is it goes from left to right. It checks from left to right. First thing, you have to type in an int because it's asking for an int. Then it asks you for a string, so you have to type it into a string. And what happens here is that internally the computer goes num is equal to 5, and internally it goes hello is equal to ASDF, because that is what you told it to print. Those are the values you gave it in the function. If we set this to 10, instead of num equals 5, it will become num equals 10. And that's kind of how parameters work. Basically, they're very simple ways for you to set variables. They can also be extremely flexible. They also make functions extremely flexible. So instead of having to print my name is Ryan, and then having to print another make another function, print name. My name, print my name is Aditya, say. Instead of having to do that for every single name, say you wanted to say my name is Chloe, my name is Brian. Instead of doing all that, instead of making separate functions, you just make one function that takes a string, name. We'll call the string name. And then print my name is, and we learn concatenation, right? In order to concatenate, it's a lot like addition. You use the plus sign. Add name to the function. And basically what will happen is when you go into my function is now asking for a string. So you remember that a string is just quotes, right? Quotes something. And now it'll print my name is ASDFJKL. Wow. So now we got it to print. Hooray. And now we don't have to, instead of having to type in a new function for every name, we can just type in Brian, we can type in Chloe, we can type in Ryan, we can type in Evan, we can type in anything. You can make your name attack helicopter. And then it would say my name is attack helicopter without you having to make another entire separate function. And that's the power of parameters and functions. Okay, cripes. I really wish I could teach you conditionals, which are extremely useful. But I think you'll be able, conditionals are very intuitive, and you'll kind of come across them as you code. So I think you'll have to pick that up by yourself. The last thing I'm going to do is show you kind of how another way Unity connects to code. Do this exactly. First, pay attention to the cube, the cube with the script. So the cube contains components, right? It contains a box collider, it contains a transform. Watch what happens. Let's take box collider. Let's type in box collider without any spaces. Notice how it appeared in the autocomplete. That means that computer knows what a box collider is, even though, which is kind of cool. Box collider. We're going to be making a variable. Call. Let's call it call. We can name it anything we want. We can use JKL if you want to, but preferably you want to make your variables descriptive. Let's call it call. Equals get component. Get component box collider. In parentheses, in the parentheses, as with any function. Notice that this looks a lot like a function, except it's got these carets. I won't go into detail about what these carets do, but basically, it replaces get component with the component that has this name. So if you look in Unity, the computer will go through all these components. It sees that box collider is here. Okay, so now I will replace get component with the box collider. And here's what's cool. Here's what's really cool about it. Let's try printing. Notice how the box collider has a couple of things, right? It has material, it has center, it has size. What happens when we print call.size? Size appears in the autocomplete. Okay, let's put size in here and try and print it. Okay. Size printed when I printed call.size, it just printed the values of all of the values in this size on this size field. It printed 1, it printed 1, it printed 1 with decimal places, obviously. Well, not obviously. Okay, if we print call dot material and save it and run it, it prints something weird. It prints physics material. And if we look here, it has a physics material, even though it's none. So that's kind of the we're treading on territory called object-oriented programming, which is basically a system where the computer. Let's go back to our model of your computer as a god. Whoops. So if we go here, your computer is a god, right? Your computer, and it can create things in this space, right? We told you it can create numbers, right? It can create strings. However, what a computer, probably the most powerful thing a computer can do is it can take all of these things and combine them into one super thing. So let's use an example. The computer can make a dog. How? We don't have a dog object, but we can represent a dog object by using things like this. It can contain a string with its fur color. Well, brown really, because red dogs are rare. It can have how many legs are in the dog? 4. How many eyes does it have? 2. And it takes 4 legs, 2 eyes. This might be stored as an int. This might be stored as another int. This would be stored as a string. Takes all of these and it combines them into this one object called a dog. And that is the basics of object-oriented programming. So we go back to our Unity. Box collider we can actually consider an object. It's made of a size, it's made of a center, it's made of a material, and a bunch of other things that Unity doesn't show you. But it's made of all those things, and it combines them together. And using code, you can actually extract those things from the components. Using first you get the component by using getComponent, and you store it in a variable. And then you access it using dot whatever you're looking for. Again, if you're looking for material, dot material. If it has material, it'll show you. Now, this isn't all powerful. If you try and type in something that's not there, if you try to type in, look for num corners, nothing shows up in the autocomplete, you'll get an error. However, for things that the object does have, like the material, call dot material, you can use dot notation to access it. Basically, dot tells the computer to look inside the collider, like the collider here, the box collider, and look for anything called material. And if the collider object has a material, it'll replace call.material with the material. If you want to look for its size, you can type in call.size, and it will spit out the size. It will replace call.size with the size. Now, I guess I'm going a little over time, but just a little practice. If you want to go now, you can. But if you want a little practice, first make a Rigidbody component by clicking Add Component, and then typing in a piece of Rigidbody, selecting Rigidbody, not 2D. Okay, so now you have rigid bodies, right? You can set the mass. Well, if you wanted to see, I guess, you can see it, watch the block fall, because that's what rigid body does. It makes objects affected by gravity. Notice how you have all these different values. You have mass is 1, drag is 0, angular drag is 0.05. Use gravity is checkmarked, which means use gravity is true in terms of booleans. Is command acted is empty, which means false. Try to print as many of these pieces of the component as you can. I'll give an example. In order to access components, first you have to type in name of the component, because you're making a variable storing that component. So you have to type in rigidbody, and then you have to give it a name, RB, I'll just call it, is equal to get component rigidbody. Remember that these this word, and the name of the component you want have to match, or at least be similar. Now, if I print RB dot, let's say I wanted to try printing the mass. RB dot, I'm looking for mass. I'm looking for dot tells the computer I'm looking for something. Mass, I'm looking for mass. And then you can try and print it. It prints RB. It prints the rigid body's mass. The mass is 1. It prints 1. So now, try printing everything you can about the rigid body. And also, try printing everything you can about the transform. Because if you see in Unity, the transform component is also here, right? So if it's a component, it can be gotten with the get component function. You just have to know how to get the component. And that I have taught you. So I guess with that, you've learned a lot of things. I suppose there are some crucial things like if, while, for that you would probably want to learn as you go. But I feel like I'm already going over time. But if, while, for, as you code, at the very least, you'll probably be able to come across it quickly. So with that, I guess I'll have to end there. If you have any questions, or if you want to ask about if, while, and for, what they do, you can stay behind and ask mentors. Thank you for coming. Again, remember the assignment. If you wanted to work on it for these last few moments, is up here. Thank you for coming to this lesson. And I hope to see you next week. Next week, I believe we'll be learning what? Game objects? Oh yes, we'll be teaching you how to read an API, and what an API is, and how useful it can be, really. And we'll be teaching you about some basic components of game objects. Some basic things about game objects. So thank you for coming. Class is over, and the lights will now go on. Class. Damn, I'm not a teacher.